Okay, so I'm going to go ahead and start. That way, hopefully y'all might have time in class to work on some of the problems on the worksheet. We're going to cover 7.5 and 7.6. So the first part is just the change of base formula. It's very simple, okay? If you have log base c of a, you're going to take, in order to change the base, you're going to do log of a over log of c, okay? So you just take, I say the big number because it's written bigger, but you're going to take this one, so log of 8 over log of what you consider your base, which is 3. Okay? So if you use your graphing calculator for this, the Inspire, I'll make it smaller. It's not going to go smaller. Okay, so if you look at your Inspire, right above that 10 to the x is your log, which would be yellow on y'all's calculators, I think, or gray or something. So you're going to do control log. Now, this automatically puts a spot for a base. You do not have to put anything there, okay? You're going to do log of 8 divided by, do it again, log of 3. Now, you could have done control divide and set it up if you like it presenting that way, just to ensure that you're not making any mistakes when you type it. Either way, you get the same answer, okay? This section will probably be on your non-calculator, like non-graphing calculator portion, so I'm going to show you also how to do it on here, which is not any different, okay? I would set up my fraction template, and then remember to do log, you do second, then log. So I'm going to do log of 8, close your parentheses, go down to the denominator, do that again, log of 3, and I get the same answer. Okay, so I'm going to round it. It says to round answers to 4 decimal places, so I'm going to have 1.8928. So I want to see you set this up, and then you just type it in your calculator, okay? Now, if I give you something like this, I've got log base 8 of 14, and I want it converted to a natural log. So the only difference is just like this formula. Instead of typing in log, you're going to have natural log. So I'm going to do the natural log of 14 over the natural log of 8. So in this calculator, just your scientific calculator, you're going to do your fraction bar second log, but now instead of a log, you go to the right for your ln, your natural log. And then you treat it the same exact way. So I would get 1.2691. Did y'all get that? Y'all are good? So that's really simple. Now, these next 4 examples, I need you to memorize the concept. The last 2 you're going to memorize specifically, but these we're going to generalize it at the end. You need to understand the concept of it. So remember that we do log base solution equals exponent. So if I have log base 6 of 6, that's going to equal 1 because of this concept. If I put it in exponential form, I've got 6 to the first power equals 6. So if I had this equal to x, if this was equal to x, then there would be your x equals 1. Okay, so if you have log base b of b, that's going to equal 1. Okay, so that's your generalization of that rule. If you take a log with a base b and you have that same value in the solution area, then that is just a 1. Okay? So if I have log base 3 of 3 to the second power, that's really like the same thing. You've got 3 to the second power, if I were doing an exponential form, 3 to the second power is equal to 3 to the second power. What's happening is when you take log base b of b to the n power, you're just left with that n. So if you need to see it as if this were just an x, you would have 3 to the x equals 3 squared. There's your x equals 2. That's where that 2 is coming from. Okay? So could you work it out? Yes. If you set it equal to x, you could figure it out. But if you just memorize it, it makes your work a whole lot easier. Okay? Now, natural log of e equals 1, natural log of 1 equals 0. You just got to memorize those. Okay? Those are really the same concept. If I had natural log of e equals x, well, this is really a base of e, so e to the x equals e. Well, that's just a 1. There's my x equals 1. Okay, so it's really the same concept there. That's as if, I should have put an x here, sorry. But same thing here, natural log of 1 equals 0. Well, if I have a base of e, and if this were just natural log of 1 equals x, I have a base of e to the x equals 1. Well, the only exponent you can have there is 0. Are y'all following me? Okay. So you're going to have to memorize the generalization of 1 and 2, but 3 and 4 you just memorize. Okay? Now, we've got properties of logs that we're going to use to condense and expand. We're going to have a section where we expand, we're going to have a section where we condense, and we're going to have a section where we're solving, and you just have to know, are you condensing, are you expanding, what are you doing? Okay, most of it when you're solving, you're condensing. But you need to know, and to me I feel like they go hand in hand just like properties of exponents did. When you multiply these two, you're really separating it by adding. So if I have log base b of mn, I'm separating that log base b of that m, so I'm going to separate that, plus the log base b of my n. Okay, so it's the same log, same base, it's just you're separating the two things that could be multiplied together, and you're adding them. So if multiplying means adding, division means I'm going to subtract, just like with properties of exponents. So I would separate my m and n, so it would be log base b of m minus log base b of n. So anytime you are dividing something, that's going to be a subtraction when you expand. Okay. Now the power property, that is if you have log base b of m raised to a p power, you're going to take that p and you're going to put it in the front. So just what that says. Okay. When you get to calculus, y'all are going to have a power rule, which is very similar to that when you do integrals. Okay, so that's not going to be the first time where you see an exponent coming out in the front, but for right now, that's what you're going to look at. Okay, those are the only three properties that we're going to use. So if I take log base 6 of 5x cubed over y, I need to expand that. Okay, this is not a time where you can skip your work either. Okay, because I have to see every little thing that you do to follow what you're doing. So if I have log base 6 of this, I'm going to take and separate this entire 5x cubed from my y. So I'm going to take log base 6 of 5x cubed. Now I'm dividing, so I'm going to have a minus log base 6 of y. Okay, now I need to separate my 5 and my x cubed. So I'm multiplying 5x cubed, so I'm going to have a plus in between there. So I'm going to have log base 6 of 5 plus log base 6 of x cubed minus my log base 6 of y. You're going to be writing log a lot this lesson. Okay. Now the only thing we have left, most people forget about, is this exponent right here. I need to use my power property, and it needs to come out in the front. So I'm going to have log base 6 of 5 plus 3 times my log base 6 of x minus log base 6 of y. And then I have nothing else to separate, so that would be my answer. Okay, y'all good with that? Okay. So here I've got log of just 3x to the fourth. Well, I don't have a base written, so what is it understood to be? 10. That's your common log. I'm not going to write the 10, but I want you to recognize that that is understood to be a log base 10. So here, I am doing what with 3x to the fourth? Multiplying. So what do I need to separate it with? Addition. So I'm going to have log of 3 plus log of x to the fourth. So then I need to take care of that exponent. This exponent 4 needs to come directly in front of that log x. So I would have log 3 plus 4 times my log x. I wouldn't be able to do anything else, so that would be my answer. Okay, y'all good with that? Now with your radicals, remember that the square root of x is the same as x to the 1/2. So if I have the cube root of x, that's the same as x to the 1/3. You're gonna have to be able to go from radical to rational for this. So I've got the natural log of the cube root of x to the 5th. So what this is doing is I'm taking the natural log of x to the 5th and raising it to the 1/3 power. Well, I need to take care of those exponents. I have a power to a power, so that's really natural log of x to the 5/3 power. Now that I've reduced and gotten it down to one exponent, I can take that exponent, bring it to the front, and I've got 5/3 natural log of x. So if I have log of x cubed over 2y to the 5th, I'm going to separate where my division symbol is. So I'm going to have log of x cubed minus log of 2y to the 5th. Okay. Well, I can do this 3 out in front. That's going to become 3 log of x. Now, this entire 2y to the 5th is in the denominator, right? Anything that's in the denominator is going to have a minus in front. The reason being is I'm really separating this 2 and this y to the 5th. So I really have log of 2 plus log of y to the 5th. I'm subtracting that entire thing. Well, with your properties of distribution, then that's what makes everything in the denominator have a minus in front, because what I'm doing is I'm doing 3 log of x minus that log of 2 minus, now I'm going to go ahead and take care of that 5 and do 5 log y. So if you understand this concept and anything in the denominator is going to be a minus, you can go straight from here to there. Okay, you can skip that. Okay, I don't need you to show me that you're distributing a negative there, because I would hope that you would understand it's in the bottom, you subtracted it. Okay? You good with that? Okay. And I get, most of y'all should probably be able to go straight from here to the answer. You should be able to, but I got to see something in the middle, okay? I've got to understand your thought process, because when you just give me an answer, I don't know how you got it. That's the whole reason you show your work, okay? Now, on the flip side of that, condensing it. You're going from that full-blown expanded problem all the way down to 1 log, okay? So you don't stop until you get 1 log, okay? So I have log of 3 plus 3 log of 4 minus log 6. So what I'm going to do is I'm going to take this 3. I recognize that it's in the front, so that means it had to have been an exponent, right? This had to have become 4 to the 3rd. So I've got log, I personally am going to take care of 3 times 4 to the third in this one step, minus log of 6. So I'm going to let you take care of 2 things in one step, but don't go overboard with it. Alright, so 4 to the third is what? 64. 64 times 3 is what? 192. Okay, what if I can do? Y'all, hold on. Okay, so what did we say 3 times 4 to the third was? 192. Minus log of 6. So that minus tells me what? I'm dividing. What am I dividing? 192 and 6. So what does that give me? Log of? That doesn't simplify? That should be 32. I don't know if y'all said that or not. I couldn't hear y'all. Okay? So when I have 2 natural log of 5 plus 3 natural log of x minus 6 natural log of y, all of those coefficients that I'm going to call them are going to be those exponents. Okay, so that's going to be my first step. I'm going to have natural log of 5 squared plus natural log of x cubed minus natural log of y to the 6th. Alright, well we know 5 squared is 25. And we know we're adding, so 25 and x cubed should be multiplied. So I should have natural log of 25x cubed minus my natural log of y to the 6th. Yes? Alright, so that minus tells me that I am dividing, so natural log of 25x cubed over y to the 6th. Y'all good with that? So, I've got 2 times log base 3 of 10 minus log base 3 of 5 plus 1/2 of log base 3 of 9. Okay? So, I need to take care of my parentheses first. So, what am I doing in these parentheses?
Squaring the numbers.
Inside parentheses. Subtraction, so that means division. So, I'm taking log base 3 and dividing 10 over 5. Plus, I'm going to go ahead and make that 1/2 as a fraction, log base 3 of 9.
Miss Levy, do you have someone taking the quiz out here or something? Yeah, I think this is your calculation.
Yes.
Oh, and it's select.
Thank you. Okay, so I'm taking 10 and 5, that gives me 2. So that also becomes the exponent. I'm going to take care of that all in one step. So that's going to be log base 3 of 2 to the 2nd power is going to be 4. Plus, when I take this 1/2 and it becomes the exponent of 9, I'm doing 9 to the 1/2, right? Anything to the 1/2 power is really the square root, correct? So I'm doing, you can either write log base 3 of the square root of 9, or you can do 9 to the 1/2. Okay? Either way, it's the same thing. Well, the square root of 9, we're going to leave it as 3. We're not going to do plus or minus 3 because you can't take the log of a negative. Okay, I was looking at some of y'all's quizzes, and some of y'all were dropping off the concept of the square root being plus and minus. Okay, so don't forget that you've got that. But here, for this particular situation, we're only going to do the positive because you cannot take the log of a negative. So this is going to be log base 3 of 4 plus log base 3 of 3. Well, I'm multiplying because it says I'm adding, so I'm going to multiply 4 times 3. My answer would be log base 3 of 12. Y'all good with that? So those are the easy sections. Okay? This is not necessarily super hard, but you gotta have, you're gonna manipulate some numbers. Okay? So when you evaluate using the given information, I'm gonna give you a specific value for a specific log. Okay? Then I'm gonna tell you to find a different log, but you can only use the numbers that are in the base and the numbers that are in the solution position. You're going to be manipulating with just those numbers, okay? So if I'm doing log base 3 of 45, that's what I want, okay? What can I multiply to get 45? 9 and 5. I can multiply that, so I can then separate, I'm going to expand it, log base 3 of 5 plus my log base 3 of 9. Well, I've got this taken care of because I know that that is exactly what was given to me. But I don't have a 9 here. I've got to be able to use a 3 or a 5. Can I manipulate 9 into a 3? What is it? 3 squared. So it becomes log base 3 of 3 squared. This is why I told you you're going to have to learn the general concept of what I have on my fingers don't work. What I have here. I've got this right here. So remember that if you have the log base of b to the n, that just gives me n. Okay? So this is really log base 3 of 5 plus 2. Okay? Well, then I can substitute that 1.465. So I've got 1.465 plus 2. So my final answer would be 3.465. Do we have questions on that? Okay. So here I'm going to give you log base 4 of 5 equals 1.161 and log base 4 of 15 is equal to 1.9534. And we're going to find log base 4 of 5 over 16. Now I might give you something that you don't use, so don't get confused by that. Okay? I might give you more than enough information. You don't have to force it to use it. Okay? So if I have log base 4 of 5 over 16, how can I start with this? I need to separate it. Alright, so I'm going to have log base 4 of 5 minus my log base 4 of 16. So remember, I can only work in 4, 5, and 15 because that's what I have here. Okay? Well, this, I'm covered. I need to manipulate this. Can I manipulate it to use a 4, a 5, or a 15? Of 4, right? Because 16 is 4 squared. So I'm going to have log base 4 of 5 minus log 4 of 4 squared. I know that y'all want to take the square root to get your 4, but you need to show this right here. Because what happens, the same concept. Okay? So log base 4 of 5 is 1.161 minus, what does this entire thing turn into? Just a 2. So 1.161 minus 2 is going to give me hopefully you get negative 0.839.
So can we just like add down a section of
Yes. I gave you more than what you needed. You don't have to do anything with the 15. So this next one, I give you log base 12 of 8, and I give you log base 12 of 10, and I want you to find log base 12 of 80. This one is very easy. What do? You got 8 times 10, so I'm going to have log base 12 of 8 times 10. So in order to separate that, I'm going to have log base 12 of 8 plus log base 12 of 10. That's exactly what I gave you. So you can just take 0.8368 plus 0.9226. And that's going to give me 1.7594. Are good with that? Okay. So when you're solving logarithmic equations, you got to check your answers to see if it causes a 0 or a negative in that solution area, because remember you can't take a log of a negative or a 0. So you're going to have to plug it back in to check your original answers. So you're going to use the properties of exponents and the properties of logs to solve each of the following equations. And you're going to round your answers to 3 places behind the decimal. So you are going to do everything you can to condense it to where you can solve. Okay? So I've got 2 log base 3 of 6 minus 1/4 times log 3 of 16 equals log 3 of x. So I'm going to take care of my exponents. So log 3 of 6 squared minus log 3 of... Now when I bring 16 to the 1/4, I am taking the 4th root of 16. I would rather work these in radical form. It does not matter what you prefer. Okay? Then that's equal to my log base 3 of x. So, on the left side of this equation, I have a subtraction, so I know that I'm going to be dividing. 6 squared is 36. What's the 4th root of 16? Equals log 3 of x. Or well, what's 36 divided by 2? 18 equal log 3 of x. What do I know? X equals 18. Why? They're like bases, so x equals 18. Okay? So then the next example, log z plus log of z plus 3 equals 1. What am I doing with z and z plus 3? I'm multiplying because I have a plus, so I have log of z times z plus 3 equals 1. Well, z times z plus 3 is z squared plus 3z. What am I going to do? So this is where you remember log base solution equals exponent. What's my base? It's understood to be 10. So 10 to the first is equal to z squared plus 3z. Well, I need to get that all equal to 0 because I've got a quadratic. So I'm going to have z squared plus 3z. It's now going to be minus 10 equals 0. Factor it. Z plus 5 times z minus 2 equals 0. Set them equal to 0. Solve, so z equals negative 5, z equals 2. I now have to plug it back in. I didn't emphasize that on the first one, but you got to look at it. I have log of z, so I cannot have that negative 5. I can only have z equals 2. Now these, I'm pretty sure are going to be on the graphing portion, the graphing calculator portion, so your Inspire portion. You could store these values for x, plug them into your original. That's a way you could check it. Okay, y'all know how to store in the Inspire? Yeah, so you could do that and check it if you wanted to. You can even do that. If I don't give you that on the Inspire, you know how to store with these. But if you have something like this, you can't do that on the scientific, so I'm pretty sure I put this on the Inspire for the case of checking your answers, okay? Alright, I'm just giving you natural log of x equals 6. How am I going to figure that out? The log base solution equals exponent. What's my base? E. So e to the 6th equals x. So x equals, so in your calculator, if you're just using this, I'm going to show you both ways since I don't remember what we're doing on which portion. Go to natural log, then go down to your e to the 6th. Okay? With your Inspire, you're going to have just one button there. You've got the E button already there. So 403.429. Y'all good? So here, I've got log base 3 of y equal to, look at what's happening here. I've got 1/4 log 16 plus 1/3 log 64. So these exponents. What is this going to turn into? Log of the 4th root of 16 plus, oh, I forgot my 3, log 3 of the cube root of 64. Oh, there should be. Sorry. You would not be able to solve that if it was not. Okay, you have to have the same base for all of that. So then the 4th root of 16 and then the cube root of 64. Okay. So this right side of my equation, I've got log base 3 of 2 plus log base 3 of 4. What am I doing there? I'm multiplying them so it turns into log base 3 of 8. 2 times 4 is going to give me that 8. So what's my answer? I know that it sounds redundant to show every little thing, but I prefer you to do that so I follow you in case you make a minor mistake. Okay. You have any questions on that section? Alright, now what about when you cannot get like bases? You're going to isolate the base of that exponent, then you're going to take the log or the natural log of both sides. Use properties of logs to solve for x, and then you're going to get the value that whatever you're solving for. So if I have 6 raised to the x equals 42, okay, this is already isolated. So what I'm going to do is I'm going to take the log of both sides. So I'm going to take log of 6x equals log of 42. So remember, you're trying to solve for x, okay? So I need x by itself. Well, it's in the exponent position, so that should come out in the front with my power property. So I'm going to have x log of 6 equals log of 42. If I want x by itself, what do I need to get rid of? Log of 6. So I'm going to divide by the entire log of 6. That does not give you log of 7. Don't do that. Okay? You're going to type log of 42 divided by log of 6. For time's sake, I'm just going to tell you that it's 2.086. You can go back and check, make sure you know how to type it in, but for time, I'm just going to tell you what that is. Okay? So if I have 6 raised to the 3x plus 1 equals 8. That base is already isolated, so I'm going to do the same steps. I'm going to take log of 6 raised to the 3x plus 1 power equal to log of 8. Now my entire 3x plus 1 is going to come out front. I write that in parentheses because I know what's about to happen. Okay, so when you have more than one term in your exponent, you need to, when you put it out front, you need to put it in parentheses. Because I have an x here, but I can't just separate 3x and 1. Okay, so what's going to happen is you're going to take this log of 6, and it's like you're going to distribute it to what's in parentheses. Okay, so I'm going to have 3x log of 6 plus just a 1 log of 6 equals log of 8. Okay, well, I need to get this by itself first, so I'm going to subtract my log of 6. So 3x log 6 is equal to my log 8 minus log 6. That does not turn into log of 2. Okay, they stay separate. Now I want x by itself, so what am I going to do? Divide by 3 log of 6. I take care of that all in one step. Okay? So that entire thing in the numerator over 3 log of 6. So x equals log of 8 minus log of 6 over 3 log 6. Do y'all need to type that in your calculator so you understand how to? I'm going to give y'all a chance to type that in your calculator. You can do 4. If I don't specify, do 4. That will be on the Inspire portion. I just checked. So whatever you want to practice with, you can obviously have both Scientific and Inspire when you're on the Inspire section. So whatever you're more comfortable with, practice with that. But you should get what? Now, is there another way you could have done that? I'm laughing because he's like, You could have just divided by log of 6 here, subtracted your 1, divided by 3. But the reason I did it this way is because you're going to have to do it the next way. You're going to, so you, yes.
I already wrote that first.
Yes. You can do it 2 ways. So, would it have been less work? It would have been less writing, okay? But when you get here, you're going to want to have understood this. So that is why I did it this way. My scanned copy of the notes has it the other way. So you could have done it dividing by log of 6, so get this, subtract 1, divide by 3. It's a whole lot less writing, okay? But I wanted you understanding that because of what we do here, okay? So if I have 8 raised to the 2x minus 5 equals 5 to the x plus 1, I'm going to take the log. I would not, if you write big, do not write big here, okay? So log of 8 to the 2x minus 5 equals log of 5 to the x plus 1. So I'm going to take both of those exponents, bring them to the front. So I'm going to have 2x minus 5 times log 8 equals x plus 1 times log 5. Now, I got x's on both sides. This is where you have no choice but to distribute both of those. Okay, so here the difference was I only had one x. Here I have 2 of them. Okay, so that becomes 2x log of 8 minus 5 log of 8 equals x log of 5 plus log 5. Okay? I need my x's on one side, everything else on the other. So I'm going to take this x log 5, subtract it to get it over here. And I'm going to take this negative 5 log 8, add it to get it over there. Alright, so I'm going to have 2x log 8 minus x log 5 equals log 5 plus 5 log 8. I have an x in 2 terms. How am I going to take it into 1x? I can't do 2 minus 1. This is where you're going to factor out the x as a GCF. Okay, so I'm going to take out my x, and that's going to leave me with 2 log 8 minus log 5 equals log 5 plus 5 log 8. Then I'm going to divide by the entire 2 log of 8 minus log of 5. So that log of 5 plus 5 log 8 over 2 log 8 minus log 5 is going to equal 4.7095. that's a lot of algebra. Like, I know we're in algebra 2, but like that's a lot of basic algebra. You're just moving stuff at this point, okay? It looks a whole lot worse because you have the word log and it takes up a whole lot of space. But I'm not denying that that's a lot, but I don't think that's really difficult. Okay?
At least it's not something you see.
So, I'm trying to think of which one is the most important to cover because we're running out of time. No, I'm going to skip this one. If I have time, I'm going to come back to it. If not, you have to look at that on the Google Slides. Okay? But I want to at least get to these two real quick. So, I've got 4 times e to the negative 0.3x minus 7 equals 13. I need to get e to the negative 0.3x by itself. So I'm going to add 7 first. Some of y'all are still messing up how to do this. There were so many of y'all a few units ago just dividing by 4. You've got to add or subtract first. Okay, so I'm going to have 4 e to the negative 0.3x equals 20. Divide by 4 and I get e to the negative 0.3x equals 5. Alright, I'm going to take the natural log, right? I have an e, so that's natural log. I'm going to take the natural log of both sides. So I'm going to have the natural log of e to the negative 0.3x equals the natural log of 5. I need this exponent out front. So negative 0.3x natural log of e equals natural log of 5. What is the natural log of e? 1. So this is just 0.3x equals natural log of 5. So if you need to, circle it and put a 1 so you know that's why it just disappeared. If you're looking back at it, you're probably going to wonder why it disappeared. So that's just a 1. So then divide by negative 0.3. X equals, if you type that in, it is negative 5.3648. Yes.
Could you have just done the log-based solution?
Huh?
Could you have just done like the log-based solution of that? Like whenever it said e to the negative 0.3.
If you do log base of 5 equals, yes, you can, if you see it that way. So there's, just like this one, I didn't do this way originally. There's more than one way. It's however you see it at the time. But I'm trying to give y'all a little bit of consistency because each problem is going to be different. So, this one's very simple. I'm going to subtract 2, 7 to the 5x minus 1 equals negative 7. 7 and negative 7 are not the same. Okay, so you got to take a log of both. Log of 7 raised to the 5x minus 1 equals log of negative 7. What would you do there? No. No solution.
I was right, wait.
You can't take the log of a negative. You can take a negative log, but you can't take a log of a negative. So, there might be problems, I don't know if it happens on your worksheet or not, but there might be problems where you get all the way down to x equals a number, you plug it in, and it doesn't work, or you get x equals a negative, doesn't work. You can get no solution. You're solving equations, you can get no solution. Okay? I will not give you IMS or all reals in this, but there's a chance that you could have no solution. We're going to push through, and I'm just going to do this one. So I've got the 4th root of 3 to the 4x plus 5 power equals 7 to the x power. I'm going to manipulate this into 3 to the 4x plus 5 raised to the 1/4. Well, it's not raised to the 1/4. It's multiplied by the 1/4 because of that's already your exponent. Equals 7 to the x. So that turns into 4 times 1/4 is just x plus 5/4 equals 7x. Take log of both sides. So you're going to treat this one very similar to this one because you have two x's. Okay? So you're going to have log of 3 raised to the x plus 5/4 equals log of 7 raised to the x. X plus 5/4 comes out equal to x log 7. So x log 3 plus 5/4 log 3 equals x log 7. I'm going to move this x over to the right so that's easier. So I'm going to have 5/4 log of 3 equals x log 7 minus x log 3. Five-fourths log 3 is equal to x. Take that out as my GCF. Log of 7 minus log of 3. So x will equal that 5/4 log of 3 over log 7 minus log 3. All I did was divide. So that should give you x equals 1.6208. So we're supposed to have a quiz over this. Next class is review day, so Tuesday will be review day. I can answer whatever questions, then y'all can take a quiz. Y'all can take a quiz before lunch, you can take a quiz after lunch. I don't really care. The later you push it, the less chance I'm going to get it graded before you leave. That's the only downfall of pushing it to after lunch, okay? But you've got your worksheet. You really don't need a fancy calculator to do these because these are all basic log, okay?